So I'm Markku Saarinen. I'm a cryptographer at BQ Shield. I live in Oxford. So we started this company 5 years ago. I was pretty much the first employee on that. And to be perfectly honest with you, I didn't do any digital design before that. So I've been a cryptographer for 25 years. So that's where I have my PhD from. So I've been writing software and cryptographic software and all of that. And I was of course interested in RISC-V. But I had some, it was an early stage startup. I had some time to do stuff. So I just basically implemented my own little core in Verilog. I was learning Verilog while I was implementing this.
Teaching yourself.
Yes. Of course, that particular CPU never was commercialized. It was a learning experience for me, but it was fantastic because one learns how computers work basically, and later on, for example, when we were standardizing the crypto extensions, so I was very much involved with. I'm still involved in standardizing crypto extensions. Having that experience of designing a little CPU was helpful. When I had to explain to people how, let's say, instruction encodings work. Each instruction has a specific opcode in there. What kind of things affect how you select those bits and things. So yeah.
Well, I'm a complete, absolute beginner in RISC-V. I've been tinkering a little bit with some dev boards and FPGAs. Also emulating on QEMU and so. But what's the thing that actually attracted you to RISC-V? I mean, you came from cryptographics, you've done research, and before that, I mean, what was your background? Was computer science or electronic engineering?
I mean, I'm kind of old, right? So from the 80s, when I was I was this tall, I was programming Commodore 64 and Amiga. All of that was in assembly language. Basically, we were making demos and such, and so really low level programming. And of course, it would not be called bare metal. You would directly access
embedded systems. Yeah.
Yeah, I mean, so we were making these little demos and that. So I knew assembly. So I guess it was like building a little computer of my own, like the ones I had in the 80s. I was very happy with that. I could use an FPGA board that cost $100, and that's my laptop to build this sort of a little computer and make it run. So that was the initial goal.
So you was already involved in that from a very early stage. So you was very familiar with Acorn and the whole movement. I think Apple as well was kind of involved in ARM, the ARM chip.
So the ARM stuff, I mean, that happened in the 80s, and Apple kind of course rescued ARM. That's another story. It's funny, Apple Newton, for example, which was a failed product, actually had an ARM chip in 93.
I mean, there's huge benefits of ARM because that's based on RISC, the reduced instruction set for the power consumption. But what is the main benefit between RISC-V and ARM? Why any people just use ARM, for example?
I guess it's the fact that we can add instructions, we can tinker with it, with RISC-V, explore.
Yeah.
The ARM licensing is a little bit restrictive, and of course there's the cost thing. So you have to sign a license in order to use the ARM.
So RISC-V is it like open source software then in that case, or so anyone can get involved. You can
anyone, yes. So you don't need to be a RISC-V member to get involved. You can implement a RISC-V CPU even commercially without being a member. You need a license in order to use the logo, or be a member, and you can invent your own instructions, custom instructions, implement them. That's all right. But if you want others to use your instructions, then you have to be a member, such for patent reasons.
Yeah, that's understandable. But it really opens up the market. Anyone, anywhere in the world can now participate in creating their own CPU, in effect. Without actually paying any license fees or anything like that. And if anyone else is working on implementing an open source standard, the ISA, someone can just look at that instructions, and maybe if they can identify some vulnerabilities, then they can patch it up. And it's kind of like that whole benefit of being part of an open source community, isn't it?
Yeah. So there's a very low barrier. It's built in a way that one person can create a little CPU that runs C programs and it does many fun things, but also there's compromises in the design, I suppose, but one can get involved easily. I do think it does scale. The basic architecture does scale, and it doesn't have much package. Right now, it's things are pretty enormous.
Yeah, I'm quite impressed. It's a bit overwhelming. I mean, when I first came across RISC-V, I found that there was a lot of information that was like really fragmented, and now it's starting to sort of come together, and they're starting to structure modules, and there's this certification as well now by Linux Foundation, so there's a bit more structure coming in.
Yeah, that's good and bad thing. It's but you can start just hacking. Like getting snippets of code. Don't read anything, just go for it, and that's one way of learning, like programming as well.
So I mean that's my approach. I just went in and started just playing around and emulated the RISC-V, compiled some basic C code and on Fedora.
Yeah, for me it was like having my own little chip design, and first time I got it connected to a screen, like a monitor, and I had my own little graphics running in there. I was so happy. It was like the 80s Commodore 64 kid, getting stuff working. It was a similar feeling.
Yeah, so it's all very exciting stuff. Is there anything else you'd like to add, or any advice maybe to a beginner? Like you said about like just hack your way and just get your hands dirty and start working.
So I mean that. So the certification side, that sounds like of course that's helpful in commercial world. So you can. I mean, in security we have certifications. It's just to show that
you understand the basic knowledge.
But they are pretty basic actually.
Yeah. So, but do you recommend something like a structured module, maybe a university degree or?
I'm a part-time professor at University of
I've heard that.
When teaching, especially computer architecture, of course it's structured, but the fundamental idea is the same. We had a Chinese professor here explaining pretty much their approach of teaching RISC-V. It is that the students implement little computers themselves and make them work and go through all of the steps required. So of course one can do that in a structured way, and a teacher can explain the theory behind like what is this thing called, what is a memory bus, what is certain architectural features called, and also best practices on like style.
What do you see as the current problems or the current areas that need more focus, more research, maybe from your background in academia and the commercial experience you have? What areas need sort of more work on? Because I'm just to give a little bit of myself. I'm a PhD student,
right.
And I'm researching, but my background's in financial technology, so that was my main sort of. When I created that proposal, it was based around the issues that I seen in the financial market and what I can as a problem. But then later on, because I had this in the background, I was always interested in risk and instruction sets and that kind of stuff, and I was always interested in learning about how things work in at a very low level. So I tried to have a spin on RISC-V. So I'm trying to identify a real issue that I can sort of have. It's related to financial markets as well as it has some issue that's maybe or an area in RISC-V where I can sort of contribute and say, okay, this is my research and have that as part of.
I would say, but
security.
I come from security, and of course what our company does are these sort of secure elements and processing things. And actually, banks are the driving organizations, especially the credit card brands, that actually drive the sort of security standardization on certain types of chips, like those used for payments. For example, it's funny, big credit card company can just go and say that this is now the security requirement for banks who are issuing the cards and all that. So your bank card, chip card can have a RISC-V in it, and
are you aware of any bank that's doing that at the moment? Because
I'm not even sure if the banks would know. But
I'm not sure myself. I mean, I work in the banking industry. I do contract work and that kind of stuff.
I mean, we know the major providers. It's NXP, Infineon, and ST Microelectronics, some others who do these chips in there. I think all of them are involved in RISC-V in some way or another. Quite a lot of ARM is still in there. I don't know if they've moved over to RISC-V on those commercial. They might have.
I haven't come across anyone. The closest I've seen, I worked for I don't want to mention the name, but I worked for it's a very large financial institution in the States, and the closest thing is they implemented some sort of development on FPGA boards. But that was many years ago. This was way before RISC-V was on the scene or anything like that. But to do some sort of like portfolio risk calculations, that kind of stuff, so they will implement it on FPGA chips rather than doing it via a quant library, which was a C++ library like everyone else. And they've enhanced the speed to generating reports and that kind of stuff.
I mean that's completely different world. It's true that for like low latency trading, they've used FPGA boards. You see the job adverts, they physically locate the data center right next to the stock exchange of speed of light.
I work for an exchange, so I'm quite. It's very interesting. But I'd love to promote RISC-V. Wanted academia, especially in the UK. I've actually come across some universities, some major universities, like University of Edinburgh, Cambridge, all the main ones. They're aware of it. I've seen people doing research in that field. But other universities, they're also kind of like mid-size. I'd say they're also popular. But they're not aware about RISC-V. I haven't seen anyone teaching a module that mentions that. When I spoke to some lecturers, and they said, "What's RISC-V?" It's something and they know about ARM. They have that idea, but they said, "Oh, it's not. There's nothing. There's no module in the computer science department. At least, maybe you should speak to the engineering department."
I think in 2023, if you're teaching computer architecture at all, and that's a key element in computer
they need
science.
to RISC-V. It has to be included.
Even the textbooks have been updated like that.
It's a new area for me, so I'm still learning. I'm still in the beginning of my journey, and I'm just sharing it with my audience. I've got a YouTube channel. It's not that very popular. It's only about 5,000 plus subscribers, and so I'm going to share that. And thank you very much for your contribution. I really appreciate it. Thank you. Take care.
Cheers.
All right.